In this video, I'm going to cover the notes for Unit 2, Part 2, Lesson 2 of our college algebra class. And in this video, I want to focus on linear equations and how we can solve linear equations by looking at graphs. Now, in reality, the work that goes into this particular set of problems shouldn't be all that challenging, but what it's going to be good for, what this video is going to be good for, is additional practice with interval notation. Most of our results, when we talk about domain and range in a calculus class, tend to be reported with interval notation, and so I want to make sure that you're really comfortable with that here as well. So in this problem, from Chapter 4, Section 1, number 31, we're being asked in Part A to solve f of x equals 40. Now remember, f of x is the name of the function, and the f of x notation really just identifies the y components that go along with each coordinate within that function. And this line here represents a visual display of that function. So when we're being asked to solve f of x equals 40, we're asking what is the x value that makes the function equal to 40? Well, that's easy. The x value that makes the function value 40 is x, a value of 24. So the solution for part A is 24. X is equal to 24. For part B, we would say that x is equal to, not 80, sorry, 72, because it takes an x value of 72 to generate a y value, or a function result, of 80. What's the answer for part C? Pause the video now and resume playback in a moment to check your work. Well, the solution here, of course, is negative 24. When x is negative 24, the y value is 0, or the function result is 0. So now, to think a little bit more about interval notation, none of these answers were in interval notation because they were single results. But for part D, E, and F, we are going to report an interval, or a domain, or a range of numbers. So now we're being asked, solve f of x greater than 40. When are the y values greater than 40? For what x values are the y values greater than 40? Well, we know that right here, when x is equal to positive 24, that's when the y value becomes equal to 40. So the range or domain of values that make the y components larger than 40, well, that would be up here. These are where the y values are larger than 40. And all of that occurs to the right of 24. Any x value that we choose larger than 24 is going to correlate to a y value bigger than 40. So we could say that x has to be greater than 24, but that's not interval notation. That's more of a set notation, and that's not what we're after here. For interval notation, we would say something like this. We're looking for all x values that are in the list, or that are an element of the list, from 24 to infinity. Notice that we're not including the x value of 24, because when x is equal to 24, the y value is equal to 40, and we want all y values that are bigger than 40. Not equal to, but bigger than. In part E, we're now being asked to solve f of x less than or equal to 80. So if I clear my marks here, again, an x value that's equal to 80 will occur right here when x is equal to 72. But if we want the y values that are less than 80, we want the y values below 80, those y values are all associated with these x values that are less than 72. If I were to pick any x value to the left of 72, even as we race out this direction, all of the y values associated with it, all y values on the remaining portion of this graph, will be less than or equal to 80. So if I want the solution to start at 72 and continue leftward indefinitely, then I want all x values that are an element of the list from negative infinity up to 72 and stopping at 72. Remember, we always list our interval from smallest number to largest. So even though we were talking about the arrow starting at 72 and going down towards negative infinity, the interval notation would start at negative infinity, since that's on the low end of our list, and it stops or tends towards 72 on the right. That's where the interval ends. Go ahead and give F a shot on your own here. Give it a try. Pause the video now and resume playback in a moment to check your work. So for this example, we know that our y values have to exist between 0 and 80, and those occur at all of these coordinates along this section of the graph. Every one of these coordinates, no matter what they are, would have a y value that's less than 80 but larger than 0. And all of these coordinates on this stretch of the graph correlate to the x values down here. So anywhere between an x value of negative 24 and an x value of 72, we will generate a y value between 0 and 80. And this would be a good representation for that interval notation. Problem number 33 from that same section provides just an interesting twist to that last type of problem. Here we have two functions. F of x happens to be this function here that's slanting downwards. That's f of x. And this one happens to be g of x, the one that's slanting upward. We can see that by the notation that's indicated on the side of either one. And if those lines represent a collection of all coordinates, that satisfy g of x and a collection of all coordinates that satisfy f of x, there are an infinite number of coordinates that satisfy f of x and another infinite number of coordinates that satisfy g of x. All of these points in a row form that line. But in this case, there's exactly one coordinate, one location where the coordinates for f of x are exactly the same as the coordinates for g of x. And that occurs right here at the point of intersection. So, if we're being asked to solve the equation f of x equals g of x, we're essentially being asked for the x value that is going to make these two components true. We would say in this case that x is equal to negative 6. When we answer part B, we should think in a similar sense, but slightly different. To solve the inequality f of x greater than g of x, we're asking ourselves, when are the y values for f of x bigger than the y values for g of x? What x values make this statement true? Well, again, if we're thinking about the y coordinates that go along with the f of x function, all of these contain y values. And at some point, the y values along this line become less than the y values on this line. And at that point, we no longer have a solution to this system, or to this inequality, I should say. Another way to think of that is just to arbitrarily pick some x values. At this point here, is f of x larger or is g of x larger? Well, f of x is up here and g of x is down here, so f of x is still bigger. What if I keep moving along the number line? At this x value, well, f of x is still larger. What about this point here? Again, f of x is here, g of x is right here, so they're getting closer to one another, but f of x is still larger than g of x, and so on. It's not until we get to that point of intersection that things change. Here's where g of x starts to become larger for this x value than this one down here, f of x. So again, with f of x solutions being here larger than g of x solutions here, the answer to the inequality would be all of the x values that make this true. And those x values start here at this position, and we look to the left. For what x values is f of x greater than g of x? We would say all x values from negative infinity up to negative 6, but not including 6. and that would be a good result in interval notation. And to finish this video, we'll again talk about an application of these functions. So we have the function t of x equals this expression, and that represents a tax bill, t, the taxes that a single person owes if their adjusted gross income is x dollars. So if we know how much money was made and is taxable, we can plug that number in for x here, and this calculation will tell us how much money is owed in taxes. Now this equation, this expression, will only compute the amount of taxes that are owed for somebody that earns between $8,350 and $60,200 inclusive. So if somebody earns precisely this much or earns precisely this much, they can still use this equation. So for part A, even before we do any math, we can answer this. What is the domain of this linear function? What are the inputs that are permitted for this function? And that's actually given to us directly right here. We will only accept x values as long as they are between $8,350 and $60,200 inclusive. So we would say the domain is all x values that are an element of the list of numbers from 8350 to 60,200. And we are using square brackets here because they are included. For part B, what is a single filer's tax bill if their adjusted gross income is $21,000? Well, the first thing to check is whether or not $21,000 fits within this domain, and it does. And since it does, we can make a substitution. The tax bill, based on a $21,000 adjusted gross income, would be equal to 0.15 times 21,000 minus 8350 plus 835. Now, if you're using a basic calculator, like a cell phone calculator or a 4-operation calculator, you'll have to follow the order of operations on your own. But if you have a calculator that does have parentheses built into it, chances are it follows the order of operations, and you can write this in one step. I've got one of those off camera right now, and after entering this expression, I see that the tax bill is $2,732.50. Keep in mind that if we execute an equation like this when we're talking about dollars, and if we get more than 2 decimal places, go ahead and round to 2 places, because that would be appropriate for dollars and cents. For part C, we're being asked which variable is the independent variable and which one is the dependent variable. Well, the variables that we're dealing with are the letters that change, t and x, and most of the time x is our independent variable, and in this case that's also true. But it's also easy to tell when we look at the definition of the function itself. The letter or the variable inside the grouping symbol is always the independent variable, and the variable on the outside is always the dependent variable. The way I remember that is I think that we get to choose the x value to put in place of the function, and since we have the ability to choose, that's our independence, we can choose the number to go inside of this calculation or expression, and based on what we choose, we can then calculate this end result. This result depends on what value was chosen for x. So we would say x is our independent variable, and that was our income, our adjusted gross income. And we would say that t is our dependent variable, and that was our tax bill. That's how much taxes we owe. And when it comes time to graph, like we see in part D, we need to specify the window. And depending on how this question is laid out in Math Excel, they may give you the window or they may give you several options to choose from, and you'll have to decide which one's the best fit. One thing that I'll be looking for is a window whose x-axis runs approximately from 8350 to 60,200, And I don't know what the y values are going to be just yet. I'll have to kind of guess and check to see what would be the appropriate fit there. But we can do that pretty easily with the TI calculator. So I've turned it on, and again I press the on or home button until we get to this screen, and I'll choose new document. If we get an error message, I'll always say no, I don't want to save any of the prior user's work. But this time I'm going to press number 2 to select a graphs page. And the equation was 0.15 parentheses x minus 8350, close the parentheses, plus 835, and press enter. Now we don't see anything on this page because, well, the graph doesn't fit in this tiny window from -10 to +10 and so on. In fact, our domain was really all of the x values from 8,000 up to 60,000, so that's way off to the right. So let's go ahead and establish that. If we click on Menu and choose Option 4, and then Option 1, we can specify the x values for which we're focusing. So in this case, we have x values from 8350 on the minimum side, up to 60,200 on the maximum side. I'm going to ignore the y values, the range numbers for just a moment. I'm just going to tap Enter here. So this has established my left and the right-hand boundary on this graph. If I go back to the menu, choose Option 4 for Window, and this time select Zoom Fit, which is Option A, I can move down with my cursor to select A, or I can just tap A on the keyboard. That's going to automatically change the y coordinates to fit the x coordinates that we've selected. And it's not real easy to see here what the boundaries are, so I'm just going to jump into the menu one more time, choose Window, and go back to the window settings, and now I can see what the y values were established as here on the screen. And it looks like the y values exist from 59 up to 9368. Now, I don't know if those are going to be the numbers that are given to you in Math Excel for the windows that are presented there, but at least the window should be pretty close to this. So maybe if I'm using round numbers, I might say my y minimum should be 0 and my y maximum should be 10,000. That doesn't change the look of the graph too much, but it does give me a nice boundary to consider. And so 0 to 10,000. And now we have a nice graph on our calculator within the domain specified. And we should be able to choose the correct answer on Math Excel from this point. For Part E, we've seen a trick like this before. We can actually answer this without too much trouble. We know that the tax bill, T of X, is equal to $3,708.55. And we can solve this with algebra if we wanted to. We know that the tax bill, 55, is equal to 0.15 times X minus 8350 plus 835. And we can go through the trouble of isolating this X variable and solving. But I think an easier way would be to graph a second equation. Press the Tab key to bring up that menu. And in this equation, we're going to type our target, which was $3,708.55. This will create a horizontal line that represents our tax rate, or tax amount, I should say, not tax rate. And we would like to find the intersection of those two graphs. So if we jump into the menu and analyze the graph, we can select Option 4 for intersection. Whoops, sorry about that. And we'll pick a position somewhere to the left of that intersection and drag our cursor to the right. And that point of intersection exists right here. Now on my calculator, the scaling is kind of off and the format of these numbers is a little bit different. But if you remember your scientific notation, you should be able to interpret this. We have an x value of 2.5 e positive 4 and a y value, let's double check that again, 3.71 E3, 2.71 E3, and I think I've got a mistake here. This was 3.75. I've got myself all mixed up. 2.75, 3.71. There we go. 3.71, 2.75. Sorry about the mix-up there. But anyway, back to that scientific notation. This E4 and E5 is implying the notion of times 10 to the fourth power or times 10 to the third power. This is the number of decimal places that we can move our decimal to obtain our result. So 2.75 times 10 to the fourth would be 27500. Again, we're moving this decimal 4 places to the right. And this one gets moved 3 decimals to the right, so we're looking at 3710. And the solutions are a bit more precise than this, but this is all that our calculator displays. And we're essentially saying that with an income of $27,500, your tax bill will be $3,710. So it's not precisely the $3,708.55, but this is pretty good. If we need more precision than what this calculator displays right now, well, we can adjust the settings. Number 9. And instead of floating 3 digits, let's just say auto and see what happens there. And we'll make that the default. Press OK. And now when we go back and look at our point of intersection, now we see a higher degree of precision. 27507. All right, almost there. Now, to finish this video out, we're talking about slope. What is the slope of this equation? Well, if we were to distribute this 0.15 into the grouping symbol here and here, sorry, this would have been an X also, but if we were to distribute, I'll just show it up here. If we were to distribute the 0.15 into X and into this and combine any like terms, we'll be left with a linear equation that looks like this, and the 0.15 represents the slope of the line, and negative 417.5 is the y-intercept. So what does this 0.15 mean? Well, a lot of times slope is identified as a fraction, and the fraction is always our y component over our x component. Let's think about the y-axis and the x-axis here for a moment. The y-axis on our graph, I'll just generate this picture here by hand. The y-axis ended up being our tax dollars, and the x-axis was our income dollars. Both of these were measurements of dollars, but one was a tax dollar and one was a income dollar. So as we're talking about slope, m is equal to the change in t of x over the change in x. So the change in tax dollars in change, or over the change in income dollars. And another way to think of that, especially with this number here, is that for every dollar of income, for every dollar that you earn, your tax increases by 50 cents, or you owe 15 cents for every dollar that you earn for taxes. I hope this video helps. I know the first 2 or 3 questions were pretty straightforward, and then this last one did require a fair amount of thinking and interpretation. But it's good stuff. This type of work does apply to other concepts that we'll see in this class, and by reviewing these now, hopefully you have a better basis as we move forward in the future. Thanks for watching.